All right, so now we're going to be really working on probability. So number one, Sue is studying fish. She catches 30 fish and finds that 3 have an extra fin. So maybe they live near a sewage plant or something, I don't know. The next day she catches 120 fish. Approximately how many will have an extra fin? So this is the probability. So you have to set up, she caught 30 fish and 3 had an extra fin. So 30 fish. Okay, and 3 had an extra fin. I'll just write fin, extra fin. So if we remember about our proportions from earlier, if she catches 120 fish this next time, how many will have an extra fin? That's just what we did during proportions. So I'm going to cross multiply, and I'm going to get 30x over here. I'm going to multiply this by 3, and like I've been saying this whole time, anytime you can, use the calculator. And don't forget, multiplication is this little star. 360. So 360 equals 3x. So when I divide by 3 and I divide by 3, I'm sorry, that was 30. Or, I'm sorry, divide by 30. Sorry. And divide by 30. 360 divided by 30 equals 12. So approximately 12 of those fish are going to have an extra fin. Yikes. Tom observes 240 birds, and he notices that 12 of them have blue tail feathers. The next day, he spots 40 birds with blue tail feathers. How many birds did he view in total that day? I honestly do not know why this question is here, except for the fact that it says, how many birds did he view in total that day? I think it's trying to trick you. It says he observes 240 birds, then he spots 40 birds. This 12 of them having blue tail feathers had nothing to do. Oh, yes, I'm so sorry. How many birds did he view in total that day? I'm so sorry. It's asking you to figure out how many birds the next day. So Tom observes 240 birds, and he notices 12 of them have blue tails. So what percentage of them have blue tails? So 240 birds, that is an ugly 40. 240 birds, and 12 of them had blue tails. Some number of birds, and 40 of them have blue tails. Okay. Same exact thing we just did. So I have 12x, 240 times 40, again, clear, 240 times 40 equals 9,600. 9,600. And I'm going to divide by 12, and I'm going to divide by 12. Come back to my calculator, divide by 12. So he probably saw how many? 800 birds that day. X equals 800. Based on a coin flip, a biased coin is filled with the following outcome. HT, you can read. If you flip this coin 150 times, how many times will tails appear? So based on your experimental outcome, what will happen? So right now it says, let's see, tails. So 1, 2, 3. 3 of them were tails out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? 3/10 of the time, okay? If he flips it 150 times, how many times will tails appear? Same thing. 10x, 150 times 3, clear. 150 times 3 equals 450. And of course, when we divide by 10 and we divide by 10, that equals 45. So x equals 45. He should expect that tails come up 45 times out of 150. A loaded number cube. When it says biased coin and loaded number cube, a loaded number cube usually means that maybe there's more of one number on one side, or it's weighted differently than the other other side, so maybe it lands on one number more often than the other numbers. Loaded number cube is rolled with the following outcome. If you roll the cube 50 times, about how many times will 1 appear? Well, right now it's 1, 2, 3, 4, 5. So 5 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of 10 times. Well, if I roll it 50 times total, how many times should 1 appear? Well, let's find out. 10x, 50 times 5, and just in case you can't do 50 times 5 in your head, 5 times 50 equals 250 divided by 10, divided by 10. So x equals 25. You should expect it 25 times, about half of the time.